Now let's just move on further toward the question number 2, and the question number 2 says, on comparing the ratios A1, A2, B1, B2, C1, C2, find out whether the lines representing the following pairs of linear equation intersect at a point, they are parallel, or they are coincident in nature. So using the table of algebraic interpretation, now we are going to tell about the nature of the pair of linear equations. So let us suppose if we are talking about the parts, we have two parts over here. So in the very first part, we can see we have the pair of linear equations as 5x minus 4y plus 8 is equal to 0, and the second one is 7x plus 6y minus of 9 is equal to 0. So let us suppose if we are talking about the general pair of linear equations or the general form of the pair of the linear equations. So as we know that the general form of the pair of linear equation is nothing but of the type a1x plus b1y plus c1 is equal to 0, and the second one is a2x plus b2y plus of c2 is equal to 0. Now if I'll compare these two pair of equations with these pair of equations, then we can see that the value of a1, that is the coefficient of x over here, is nothing but 5. As you can see, we have the coefficient of x as nothing but 5. So if we are talking about the very first part, so let's just write a1, b1, c1. So first of all, we have a1 as nothing but 5. Then we have b1. As you can see, we have the coefficient of y as minus 4 over here, and the coefficient of y over here is nothing but b1. So if we are comparing the coefficient of y in this equation as well as in this equation, so obviously b1 is nothing but coming out to be minus 4. So b1 is nothing but minus 4. Similarly, the value of c1 constant, c1, and over here we have 8. So c1 is nothing but 8. In a simultaneous way, if we are taking a2, means the coefficient of x in the second equation, and the coefficient of x in the second equation is nothing but 7. So it means a2 is nothing but is equal to 7. So a2 is 7. For the b2, what is b2? As you can see, b2 is nothing but 6. And for the c2 is nothing but minus of 9, because we have minus 9 over here and the constant is nothing but c2 over here. So c2 would be is equal to minus of 9. So these are the values for a1, b1, c1, a2, b2, c2. Now let's just compare the ratio of a1, a2, b1, b2, c1, c2. So let us suppose if I'm taking a1, a2 over here. So a1 by a2 is definitely nothing but 5 by 7. Similarly, b1 by b2 is nothing but minus 4 by 6, and we can also make it into the lowest form as 2 into 2 is 4, 2 into 3 is 6. So this is nothing but minus 2 by 3. And further, if I'm talking about c1 by c2, it is nothing but 8 by minus of 9. So as you can see, none of the ratio, that is a1 by a2, b1 by b2, c1 by c2, they are not equal to each other. So using the algebraic interpretation table, I can say that a1 by a2 is actually not coming out to be equal to b1 by b2. a1 by a2 is not equal to b1 by b2. So if we have such kind of a situation in which a1 a2 is not is equal to the ratio of b1 b2, then what we can say about this particular thing, that we do have a unique solution and the lines are actually intersecting at a point. So whenever a1 by a2 is not equal to b1 by b2, then it means that we have a unique solution and the lines are intersecting at a point. So I'm writing the solution over here, that it implies that we have a unique solution. We have a unique solution, or we can say one and only one solution, and thus the lines are intersecting, at a point. The lines are intersecting at a point. So using this this a1 by a2, which is not actually coming out to be is equal to b1 by b2, we can say that we are having a unique solution, and furthermore the lines are intersecting at a point. Now let's just talk about the second one. As you can see over here in the second equation, we can also compare these two pair of equations with these. So if we'll compare both of these with each other, then definitely we will get the value of a1 A1 as. So let's just compare the coefficient of x, y and the constant in both of these. So if I'll compare both of these, then we can have A1 as nothing but 9. As you can see, the coefficient of x over here is nothing but 9. B1 is nothing but 3, C1 is nothing but 12, further we have A2 is nothing but 18, B2 is nothing but 6 and C2 is nothing but 24. We do not have any negative sign over here, so it is quite easy to compare A1, B1, C1, A2, B2, C2 in this pair of linear equation. Now let's just talk about the ratio of these. So if I'm taking the ratio, if I'll talk about A1 by A2, this is nothing but 9 by 18. 9 by 18 means 1 by 2. Furthermore, B1 by B2 is actually nothing but 3 by 6. So 3 into 1 is 3, 3 into 2 is 6. So this is nothing but 1 by 2. Furthermore, we have C1 by C2, which is nothing but 12 by 24. And if we'll make it into the lowest form, we'll get 1 by 2 again. It means that in each and every ratio, we are getting the ratio as 1:2. As you can see over here, A1 by A2 is half, B1 by B2 is half, C1 by C2 is half. It implies that A1 by A2 is equal to B1 by B2, which is equal to C1 by C2, which is actually nothing but half. So whenever we have such a condition, when A1 by A2 is equal to B1 by B2, which is equal to C1 by C2, it means that the lines are parallel to each other. It means the lines are actually parallel to each other. So it implies that A1 by A2 is equal to B1 by B2, which is equal to C1 by C2, which is nothing but is equal to half. As you can see, the ratios of all A1 by A2, B1 by B2, C1 by C2 is nothing but a half, half and further half. So what can we say from such a condition? So whenever A1 by A2 is equal to B1 by B2, which is equal to C1 by C2, then the lines are actually coincident in nature. The lines are coincident in nature, and it means that the two lines are actually lying on each other. So from this particular condition, that is A1 by A2 is equal to B1 by B2, which is equal to C1 by C2, what can we say? We can say that the lines are coincident, and we can say that they do have infinitely many solutions. So this is all about the question number 2, in which we have to represent the lines, or we have to compare the ratios A1 by A2, B1 by B2, C1 by C2, and we have to find out whether the lines are intersecting, parallel and coincident. So I hope the solution set of this particular question is all clear to you. Now let's just move on further to the question number 3.